Hello dear students, welcome you all to the most important MCQ discussion for the same chapter Haloalkanes and Haloarenes part 2. Okay, part 1 already we discussed. All of you see the part 1 question discussion and then please watch this video part 2 Haloalkanes and Haloarenes. Okay, so we can start from a new question, right? Here we have the first question. The major product formed in the following reaction is. What is the major product in the following reaction? I think they given a species here, that is a haloalkane, right? CH3C, CH3H, and we have CH2Br, right? It is a haloalkane. It's reacting with the nucleophile. What is a nucleophile? That is CH3O minus, right? CH3O minus, that is the nucleophile. Upcoming nucleophile. Methanol is given, that's a medium solvent. Okay. So the question, where we can add, what is this reaction actually? Nucleophilic substitution reaction. Correct or not? Because we want to remove this bromine and we want to substitute OCH3 nucleophile. That's what happened. If you directly add CH3O minus or OCH3 into the bromine position, that's a wrong answer. That's also a product. I'm not saying that it should not be, it is not a product. It can be a product, but it is a minor one. Because if you remove the bromine from this carbon, so this carbon will get a positive charge. What carbocation is this? It is a primary carbocation. Why? Because that carbocation directly connected to only one carbon. It's a primary. It's a primary now. Okay, primary. One of the exceptional case we discussed in previous. Hope you remember that. So here, that primary is one way. Primary is carbocation now. If you are directly adding the OCH3 into that position, you will get this product. What is that? CH3, CCH3, H, and we have CH2, then OCH3. This is the product we are going to get. I think that option is already given in option A, but it is a minor product. Okay, it's a minor product. Why? As I told you, in carbocation reaction, please check it that whether when you are getting a lower stability carbocation, primary, secondary, please check it that whether there is a chance to make it as a tertiary or not, either by hydrogen shift or by methyl shift. What is that? Now it is primary. Let me check it whether it is possible to make it as more stable carbocation tertiary or not. Okay, how? See this compound. How we can analyze to convert into primary into tertiary? Very simple. Just look into the nearby carbon. The nearby carbon, if it contain a hydrogen, okay, if it contain a hydrogen, try to maximum shift hydrogen. So this hydrogen, let me shift it to the nearest carbocation. So what is the charge of the new carbon? CH3, CCH3, here carbon carrying positive charge. And what happened here? CH3. Now you see the primary carbocation converted into tertiary carbocation. This is called what? 1,2 hydrogen shift. A hydrogen is shifting from the nearest carbon. That's it. If it is not hydrogen, you can shift a methyl group if you are getting a tertiary carbocation. Alright. Okay. So we are getting tertiary carbocation. So where we want to add our nucleophile OCH3 to that carbocation. So here we want to add OCH3. This is the major product. Okay. This is the major product. So what is your answer, student? Can you identify this compound in any of the option? Yes, that is option D, right? Option D. Option D is the correct answer. Okay. Minor one is also one of the product, but we cannot write because major one is the final answer. Okay. So answer is option D. Okay. Next question. Identify the product A and B in the following reaction. What is the first reaction? They given CH3CH Br, CH3, and we have CH3. It is reacting with a C2H5ONa. What is the compound? C2H5ONa? Sodium ethoxide, right? Sodium ethoxide. So what is this reaction? You got it. This is a haloalkane treating with a sodium alkoxide. That is called Williamson's ether synthesis. What you have to do here? You have to sodium and this bromine you can eliminate as NaBr, then OC2H5 you can substitute there. So you will get the major product as major product. But here also we have to check it directly. If you add OC2, this is the nucleophile, right? C2H5O minus is the upcoming nucleophile. If this bromine lose from this carbon is what? Secondary carbocation, because that carbocation directly connected to two carbon atom. Please check it if that carbocation can make into tertiary or not. Yes. How? From the nearest carbon atom, let me take this hydrogen and shift it to this carbon. So what you will get it there before? CH3, CH2, CH3. Now positive charge is here, then CH3. Correct? Now, where is the nucleophile C2H5O minus is attacking? To that carbon. Sorry, the hydrogen is not there, right? That hydrogen we already transferred. Okay, fine. So let me add the OC2H5 to this carbon atom. So your final product is CH3, CH2, CH3, CH3. Here in which OC2H5 is come. This is the final product. Okay, so primary, secondary carbocation, if you are getting, just to check it whether there is a chance to make it as tertiary or not. Alright, so this is the major product in the first reaction. Okay, let me finish the second reaction also. In the second reaction, there is a alkene, CH2 double bond CCH3, and we have CH2 CH3. We are treating with HBr in presence of peroxide. No doubt, HBr contain H plus and Br minus. In presence of peroxide, we have to follow anti-Markovnikov rule. Negative part you should add into the carbon contain more number of hydrogen. Positive part you have to add into the less number of hydrogen. So your product will be CH2Br, CH, CH3, CH2, CH3. Correct? So where you can identify this and this product? Option, which is possible here all? Option which is possible? Yes. Option B, yes. Option B is possible. Okay. So first one is Williamson synthesis, but very careful whether there is a chance to make it primary, secondary carbocation into tertiary or not. Alright. So let's go to the next question. A mixture of 1 chloropropane and 2 chloropropane when treated with the alcoholic KOH. What is alcoholic KOH? Beta elimination. Okay, let's take the compound. What is the first one? 1 chloropropane. Yes, we have 1 chloropropane. Let's treat it with the alcoholic KOH. What is the second one? 2 chloropropane. Okay, let's take 2 chloropropane. Okay, we have 2 chloropropane. Let me treat it with the alcoholic KOH. What we have to do? What is beta elimination? Take your halogen from alpha carbon, take a hydrogen from beta carbon, make a double bond between alpha beta. That's it. CH3, CH double bond, CH2. Propene is the compound. What about 2 chloropropane? Take the chlorine from alpha carbon. There are 2 beta carbon. Yes, both are same one. So let me take, this is beta carbon. So take one hydrogen, make a double bond between alpha beta. Here also, what is the product here all? Propene is the major product. So what is the question? Propene. Are you getting a mixture of propo 1 in and propo 2 in? No, only propene is the product. So propo 1 in is the product you are getting through the beta elimination. Alright, next one. Consider the following reaction. Identify X and Y. What is here X? What is here Y? Okay, let's find out. Very simple. Starting material is which one? CH3, CH2, CH2, iodo-propane. Right, one iodo-propane. We are treating with which one? Alcoholic KOH. Again, what is the reaction? Beta elimination. What is beta elimination? Take iodine from alpha carbon, hydrogen from beta carbon, make a double bond between alpha beta. Your product is propene. Alright, this is your compound X. Then X is going to treat it with which compound here on? bromine Br2. What happened? When you treated bromine into an alkene, both of the bromine can be connected. This is an addition reaction. Both of the bromine can added into each carbon atom, double bond becomes single bond. So what happened? CH3, CHBr, CH2Br. This is the product Y. Identify X and Y. Where is X and Y, X and Y, X and Y? That is in option A itself, right? Propene is the first product and 1,2-dibromopropane is the second product. Alright, so the question number 4 is over. Let's go to the next one. 2-chloro-2-methyl propane on reaction again with the alcoholic KOH. So this is a series of questions related to beta elimination. 2-chloro-2-methyl propane. Let me take the compound. 2-chloro-2-methyl, 2-chloro-2-methyl propane on reaction with the alcoholic KOH. Let's carry out again beta elimination. Gives X as the product. What is X? Simple. What is that? Take chlorine from alpha carbon atom. Total how many beta carbons are there? 3 beta is there. What is beta carbon? Alpha carbon directly connected carbon is called beta. So beta carbon containing hydrogen is said to be beta hydrogen. During beta elimination, take your halogen from alpha carbon, take one hydrogen from beta carbon, make a double bond between alpha beta, finish. What is the product? What is the product? It will be the product, right? Okay, chlorine removed, hydrogen removed, double bond. What is the name of this compound? 1, 2, 3. Second position methyl group, therefore 2-methyl propene. 2-methyl propene is the major one. Answer is what? 2-methyl propone in option C. Right? Very simple reaction. They can be made into MCQ test. Alright. So the compound on alcoholic KOH, it will undergo beta elimination. It will give you 2-methyl propene as the major product. Okay, dear all, next question. It's given again column 1, column 2, identify. Left side they given some of the reaction, right side they given the name of the reaction. Let's identify. Compound, first one, what is happened here, check it out. I think this reaction we discussed just before. This is a haloalkane treating with the sodium alkoxide, that means Williamson synthesis, correct? Williamson synthesis, but Williamson synthesis such an answer is not given here. Okay. Actually, in that process, what we considered, do you remember? We did something extra. What that? Bromine, when we deleted or removed, you are getting a secondary carbocation. We made that secondary carbocation into the more stable tertiary. How? From the nearest carbon, we transfer this hydrogen and we make it as a tertiary carbocation. To a tertiary carbocation, the nucleophile C2H5O- is attacking. Yes or no? That's what happened. So tertiary carbocation made, right? Tertiary carbocation follow which reaction? Whether SN1 or SN2? SN1. Correct? SN1. So the first one we can match with the SN1 mechanism. What about the second one? What is second one, dear all? A bromoethane, we are treating with a silver hydroxide, KOH, like that. What is happening? Bromine is eliminating, OH is substituting. What it is called? Substitution reaction. Okay, substitution reaction. So which is substitution? How can we identify? SN1 already we take it for first one because of the stability of carbocation. SN2 we can take it for this one. Why, dear? Because the haloalkane is a primary haloalkane. This is a primary haloalkane. You know, primary haloalkane prefer to undergo SN2 mechanism. Alright, next one. What is the next one? Very simple. This is an unsymmetrical alkene to which you are adding H plus and Br minus in presence of peroxide. It is called anti-Markovnikov rule or peroxide effect or Karash effect. Yes or no? So C1 we can match with the fourth one. And what is the last one? Alcoholic KOH. No confusion. Beta elimination. Beta elimination. Tell me your answer. Which option is more matching? A with the second one. A with the second one. That's it enough, right? That's enough to get your answer. A with the second one. B with the third one. So your answer is option B. Alright. Let's go to next question. Identify Z in the following reaction, which means we need the final product. Okay, let's go. What is the starting material, dear all? C2H5I, CH3CH2I. This is treating with what? Alcoholic KOH. What is the purpose of alcoholic KOH? Beta elimination. Take iodine from alpha carbon, take a hydrogen from beta carbon, put a double bond between alpha beta, you are getting the compound ET. This is your compound X. Alright. To X compound, what you are adding, dear student? Br2. I told you, to an alkene, if you are adding bromine, it is an addition reaction. Both of the bromine can goes to each double bonded carbon atom. Double bond becomes single bond. You will get the compound vicinal dihalide. A vicinal compound, you will get it. Okay, this is your compound Y. This one you treated with the KCN. Dear student, organic reaction, you know, it is not compulsory to balance. So KCN they specified. Correct. So they didn't specify how many KCN. So the KCN, what happened here? Potassium will replace bromine, or potassium remove bromine as KBr. Cyanide will substitute. How many bromines are there? 2 bromines are there. Correct. So both of the bromine can be replaced by the nucleophile cyanide, because they didn't specify how many KCN. They just given KCN. Otherwise they will specify 1 mole KCN or 2 mole KCN, like that. If KCN, if it is not specified the number, we can take it as much as required. So 2 bromines are there. Both of the bromine can be replaced by cyanide. So your product will be CH2, CH2, CN, CN. This is your compound Z. So identify where is Z. That is option B. Sorry. Okay. So your product is B is the final answer. Next one. The ease of dehydrohalogenation. What is meant by dehydrohalogenation? Beta elimination. During beta elimination, one halogen and one hydrogen is deleting or eliminating, right? That's called what? Dehydrohalogenation. So, which haloalkane, which alkyl halide or haloalkane you can easily dehydrate? You know, tertiary group, if you consider a tertiary alkyl halide, this is a tert-butyl chloride. This is a tertiary haloalkane. Correct. Halogen connected carbon directly connected to 3 carbon. This one is ready to undergo dehydrohalogenation, because you know there is highly steric crowded methyl groups are there. They are ready to leave something. Okay, please take something from me. So when you treat it with alcoholic KOH, immediately they will remove all the chlorine from alpha carbon, 1 hydrogen from beta carbon, it will form alkene. Because of tertiary steric hindrance maximum, tertiary will undergo greater, then secondary, then primary. Primary is almost a stable, right? A linear one. It's having a no steric hindrance. It is already stable. A stable compound not ready to undergo reaction. Tertiary is highly unstable, easy to undergo reaction. So the answer is option B. Say tertiary greater than, secondary greater than primary. Okay, next one. Elimination of bromine from 2-bromobutane result in the formation of. Elimination of bromine from 2-bromobutane. What is the compound? 2-bromobutane. 2-bromobutane. Okay, let's take it. This is the compound 2-bromobutane. We want to eliminate bromine. Actually, the reaction is not, or the statement is not completed. What they are actually meaning, which reaction? The elimination of bromine. Bromine cannot be individually, we cannot eliminate from the system, right? It can be dehydrohalogenation, beta elimination. So let me treat it with the alcoholic KOH. Yes. When you treat it with alcoholic KOH, what are the product is possible? Here, bromine you have to take from alpha carbon. Okay. You have to take a hydrogen from beta carbon. How many beta is there? Here one beta, here one beta. Let me take it. This is beta 1, this is beta 2. You will get 2 products, right? You study. What will happen? Let me write the 2 products. If I am taking the hydrogen from beta 1 carbon, if I am taking the hydrogen from beta 1 carbon, what I want to do? Take the bromine from alpha carbon, take the hydrogen from left beta carbon, put a double bond between that alpha and beta. Your product will be this one. What is this product? What is this product? But1-ene. But1-ene. If you are taking the right beta 2 carbon from which if you are taking hydrogen, you have to make the double bond in between that alpha and beta. So you will get CH3, CH double bond, CH single bond, CH3. This is the compound which one? But2-ene. Tell me dear, But1-ene or But2-ene, which is the most stable product? But2-ene. According to Seitz's rule, more substituted alkenes are more stable. Try to make the double bond almost at the center, middle, like that. It will be more substituted alkene. It is more stable according to Seitz's rule. So this is your major or predominant product. This is the minor product. So what is your answer? When this compound undergo beta elimination, But2-ene, yeah, predominantly 2-butene or But2-ene will be the product. Okay, keep in mind option B. Okay, complete the reaction. What is the final product? That is the question, dear student. Let us start. Starting material is given 2-bromopropane. Okay, 2-bromopropane. Whenever you feel any speed, just to stop the video, just to look into the question, see the solution, understand once again. Okay. This is the compound 2-bromopropane. It is treating with the alcoholic KOH. Alcoholic KOH. Again, what we have? Beta elimination. Take your halogen from alpha carbon. Here both the beta are similar. So let me take it. This is beta. Take hydrogen. Put a double bond between them. Your product will be propene. Alright, propene. This is your compound X. Okay. This X compound we are going to treat it with which one? HBr in presence of peroxide, which means anti-Markovnikov's rule. What is anti-Markovnikov rule? Negative part add into the carbon contain maximum number of carbon and positive part into less number of carbon. So you are getting CH2Br, CH2, CH3, 1-bromopropane. This is your compound Y. Alright. This one is treated with the sodium iodide in triacetone. Y compound is a haloalkane. Sodium iodide we studied in only one reaction, Finkelstein reaction, the halogen exchanging reaction. Correct? This bromine is replaced by iodine. So your product will be CH2, CH2, CH3 with the iodine. This is your compound Z. What is the final product? That is the question. What is the answer? Option A itself is the answer. Okay, clear all of you? So maximum already the all pattern, all the topics already be covered. We can discuss some more previous year question. Make sure that this term one examination it's our. Okay, we should compete whatever the question. Keep practicing the question again and again. Next one. Grignard reagent. We studied Grignard reagent. Grignard reagent is RMGX. Right, alkyl, magnesium, halide. Where magnesium positive one, alkyl group is negative charged. Grignard reagent is a very useful starting compound for a number of organic. Yes, we studied now Grignard reagent when treated with the aldehyde and ketone. You can prepare primary, secondary, tertiary, all kind of alcohol. Even in alcohol chapter also we discussed. Okay, what is the question? Grignard reagent, a very useful starting compound for a number of organic reactions, can be prepared by. How we can prepare Grignard reagent? That is the question. Very simple, you know, RMGX. What we are doing? Very simple. We are taking a haloalkane to which we are adding magnesium. Right? That's it. We are taking a haloalkane. We are adding magnesium. Where this magnesium is going to add in between R and X. Alkyl, magnesium, halide. That's it. So what is option A? Reaction of alkyl halide with a solution of magnesium hydroxide. No, we are using magnesium method. Reaction of alkyl halide with a dry magnesium powder in presence of dry ether. Yes? Correct. It is happening in presence of what? Dry ether. Option C, reaction of magnesium chloride. No. Reaction of alkyl halide with the magnesium in presence of alcohol. No. We are using which one? Dry ether. Dry ether is the medium we are using. Okay. Answer is option B. Next. Identify the product X and Y in the given reaction. This reaction actually a part of alcohol chapter also. Anyway, I am discussing CH3 CHBr single bond CH3 that is reacting with the magnesium in presence of dry ether. Just we discuss now. What is this reaction? Haloalkane reacting with the magnesium. Where we want to add this magnesium? In between this carbon and the bromine. So your product will be CH3 CH MgBr with CH3. Okay. This is your compound X. They are treating with the what? D2O. You know what is meant by D2O? Heavy water. What is meant by D2O? Heavy water. Let me just treat with the normal water first of all. Okay. Let me treat with the, in order to avoid the confusion, let me treat with the normal water and heavy water. Normal water. All of you look into the compound X. What are the ions in X? Magnesium is positive, so the alkyl group is negative. Okay. What is the ions in water? Water which contain H plus and OH minus. Okay, H plus and OH minus. What you have to do? Just to interchange the or double displacement to the negative CH group and H plus. So you will get the compound CH3, CH2, CH3. To the MgBr, you have to add OH minus. MgBr in which you have to add MgBr already there, to which OH you add it. This is the product, correct? Same thing you did for D2O. H2O contain H plus and OH minus ion. Similarly, what is D? Deuterium, isotope of hydrogen. D2O contain which ion? D plus and OD minus. Correct? You just interchange the same way. D plus you can add into CH minus. So you will get CH3, CHD, CH3. What is the byproduct? MgBr, to which what will attack? OD will attack. That's it. So what is the product? Where is the product? This is your compound Y. Okay, let's identify where is the first compound CH3, CHMgBr. Okay, CH3, CHD. Correct? Option B, right? Option B. Simple. So just to make first of all Grignard reagent. Grignard reagent contain magnesium. Br part is positive, so carbon part is negative. So just to interchange the anion and the cation. That's it. Option B can be the correct answer. Alright. So let's go to the next question. Chlorobenzene on treatment with the sodium in dry ether. Very simple. We discussed before. What is the compound? Chlorobenzene on treatment with the sodium in presence of dry ether. What will happen? You will get biphenyl. Correct? Two molecules of chlorobenzene will react together. 2 chlorine is their left side, 2 sodium is their left side, 2 NaCl eliminate, 2 phenyl group will join together. 2 phenyl group, 1 phenyl group combined with another phenyl group, right? That is called what? Biphenyl or diphenyl. This conversion is called which reaction? Fittig reaction. Fittig reaction. What is the actual difference between Wood's reaction and Fittig reaction? I am not asking about Wood's Fittig reaction, okay? What is the difference between Wood's and Fittig? Wood's reaction, it is used to double the number of carbon in the haloalkane. In case of haloalkane, this double number of carbon is discovered by Wood's. But in haloarene, double the number of aromatic ring is discovered by Fittig. That's the difference, okay? Option A is the correct one. Now, the main difference between carbon-halogen bond of a haloalkane and haloarene we discussed before on another question. This is haloarene, right? This is haloarene, for example, chlorobenzene. And if you consider this is CH3Cl, this is haloalkane. We discussed the hybridization, everything in part 1 video. Yes, okay. Now you see, dear student, you know very well. In haloarene, chlorine connected carbon, this is a double bonded carbon, therefore sp2 hybridized. Here chlorine connected carbon, this is a sp3 hybridized. Correct, right? In haloarene, chlorine connected to sp2 carbon. In haloalkane, chlorine connected to sp3 carbon. Okay, now, what is the, okay, this is enough to answer this question. Okay, let me just check it. Option A, CX bond in haloalkane is shorter than haloarene. That also we discussed. sp2, chlorine in haloarene, chlorine which can undergo resonance, so it will create a double bond, right? Double bond. Double bond is a stronger and shorter bond, right? In haloarene, we have a stronger and shorter bond, shortest one. But in haloalkane, such a resonance is not possible. Single bond only there. It can be high length. So CX bond in haloalkane is shorter. No, this is longer. This is what? Longer. Okay. So this is not answer. Option B. In haloalkane, carbon connected to CX bond is sp3 hybridized, while in haloarene it is sp2 hybridized. Correct, right? Yeah, correct one. Option C. CX bond in haloarene acquire a double bond character due to higher electronegativity of X than haloalkane. Not because of high electronegativity, that is because of which one? Chlorine contain lone pair, so resonance, right? Haloalkane are less reactive than haloarene due to difficulty in CX cleavage in haloalkane. You studied the point very clearly. If you consider this is a haloalkane, there is a double bond, partial double bond can be generated due to resonance. The another one, if you consider a CH3Cl, if you consider a chlorobenzene, these kind of species, CH3Cl, if you consider CH3Cl, if you consider, there is no resonance possible. Correct? No resonance possible. Okay, fine. And from haloarene, it is little difficult. You know very well, in haloarene, removal of chlorine is difficult. Correct? Because there is a double bond character and also high S character. So nucleophile cannot substitute here. If you remove chlorine, then only a nucleophile can substitute. It is not possible. You studied that haloarenes are less reactive towards nucleophilic substitution reaction compared to haloalkane, because the removal of chlorine or halogen is difficult in haloarene due to the double bond. Okay, next. Okay, dear student, match the following. Very simple. Let's go. Here we have benzene. All of you look into the first reaction. Benzene treating with the chlorine in presence of FeCl3, you will get chlorobenzene. Chlorobenzene treating with the sodium in presence of dry ether, you will get biphenyl. You will get which one? Biphenyl. What is the reaction is called? Fittig reaction. What is the answer? Third one. So this is, we can match with the A. Okay. Compound number B. What is compound B? This is a haloalkane treating with a C2H5OH. What is that? Ethanol. So alcohol containing OH. Alcoholic KOH. What is alcoholic KOH? Beta elimination. What is beta elimination? Take a halogen from alpha carbon, take a hydrogen from beta carbon, put a double bond between alpha beta. Yes. After that, what they are doing? H plus and Br minus adding in presence of peroxide. Which rule? Anti-Markovnikov rule. Where we want to add here? Br minus adding to carbon contain more number of hydrogen, H plus adding to less number of hydrogen. Which is your product? This is your product, right? So this is the B compound answer. What about option C or compound number C? Chlorobenzene treating with a concentrated nitric acid and concentrated sulfuric acid. What is this? Nitrating mixture, nitration. You know, chlorine, halogens on benzene ring act as a ortho-para directing group. Major product is para. So we are getting para-nitrochlorobenzene. Treating with which one? NaOH and dilute H plus. Dose process. What is dose process, dear all? What is dose process? When you first treated with the NaOH, this chlorine and hydrogen eliminated, nothing happened to nitro group, okay? Nothing happened to nitro group, this become ONA, sodium phenoxide. Then we are treating with a dilute acid. When you treated with acid, this Na will be eliminated and you will get here OH with the NO2. You know what is dose process? Conversion of chlorobenzene into phenol, okay? So where is that compound? That is in second one, C. Okay, next last one. Last one again, this is beta elimination, and again anti-Marconico's rule. I think you will get the first one. This is D. So what is your correct answer? A with the third one. A with the third one. Only that is the answer, option B. But just I explain to understand the remaining equations also. What is a reaction? Hope you get it. Okay. Next. What is the end product in the following reaction? Come on, the same theory, different question. What is the starting material? Benzene. Benzene to which chlorine in presence of FeCl3, what is that? Chlorination. So benzene, when you treat it with the chlorine in FeCl3, you will get chlorobenzene. Chlorobenzene is the compound P. Chlorobenzene when treated with the sodium in presence of dry ether, how many times? Biphenyl or diphenyl? Right, biphenyl or diphenyl, your answer is compound number C. That's it. Next one. Ethyl chloride is converted into diethyl ether. Which reaction? What is ethyl chloride? CH3CH2Cl. You have to convert into which one? Diethyl ether. What is diethyl ether? This is one ethyl group. This is one ethyl group on an ether. How you can convert a haloalkane into ether? Ether preparation we studied. Williamson synthesis. Williamson. What we have to use it here? CH3, CH2ONA. When a haloalkane treated with sodium alkoxide, this one sodium and chlorine eliminated, you fuse it together, you will get ether. That is called Williamson ether synthesis. Next. What would be the product formed when 1-bromo-3-chloro-cyclobutane react with the 2 equivalent of metallic sodium in dry ether? Woods reaction. Okay. Let me tell you a simple example for a normal Woods reaction. Let me take a methyl chloride. Let me take one more methyl chloride. Let me treat with a 2 sodium metal. What will happen in dry ether? This part is eliminated, right? 2 sodium taking the 2 chlorine eliminated as 2 NaCl. CH3 will combine together. What is the product? CH3 single bond, CH3. Ethane is the product. This is what happened now. Okay, now come to the question. What is your compound? 1-bromo-3-chloro-cyclobutane. What is meant by cyclobutane? This is what cyclobutane. 1-bromo. So first position bromine. 1, 2, 3. Third position chlorine. This compound you are treating with the 2 sodium. What will happen? What will happen? Dear student, 1 sodium taking 1 bromine. So NaB are eliminated. The other sodium taking chlorine and NaCl is eliminated. So what is happened? Which carbons are connecting? We are not taking any other compound because within this compound, both of the halogens are present. So from which carbon from bromine is eliminated from this carbon, chlorine is eliminated from this carbon. So what we have to make a connection? Make a connection between those 2 carbon atoms. So your product will be which one? Like this, a bicyclic compound. Your answer is option 4. Okay. Next. Benzene on reaction with a mixture of HNO3. Okay, benzene. Let me start. Starting material is benzene. Benzene on reaction with a mixture of HNO3 and H2SO4. Followed by, what is this reaction first of all? Benzene treating with the nitric acid and sulfuric acid. What is the reaction? Nitration. Yes or no? Nitration. Because this is called what? Sorry. This is called what? Nitrating mixture. So what you will get here all? Nitrobenzene. Okay. Take your nitrobenzene. Followed by reaction of chlorine in presence of FeCl3. You know, chlorine in presence of catalyst mean electrophilic substitution reaction. What is the upcoming electrophile? Cl+. Where it can attack? That depend on nitro group, because nitro group now is the king of that compound. He will decide where the chlorine has to attack. We studied that nitro group is a meta-directing group. Nitro group is a strong meta-directing group. It can direct the upcoming chlorine into this meta position. So nitro group here, chlorine here. What is the name? What is the name can be suggested here? We can say this is 1, this is 2, this is 3. 1 chloro, 3 nitrobenzene. 1 chloro, 3 nitrobenzene. It's not clearly mentioned here. As per the position, we can say the answer 3 chloro, 1 nitrobenzene. Yeah, as per the position. Actually, it should be 1 chloro, 3 nitrobenzene. But as per the position, if you interchange it, compound should be the same. 3 chloro, 1 nitrobenzene. Right? Option A can be the, as per the given option, option A is the answer. Now, in the following reaction, what is the final product is C? Okay. What is the starting material? CH3, CH2, CH2I, iodopropane or propyl iodide. First, what is treating? Alcoholic KOH. Alcoholic KOH means beta elimination. What is beta elimination? Take iodine from alpha, take one hydrogen from beta, make a double bond between alpha beta. That's it. This is your compound A. This compound A we are treating with the Br2, Br2, Br2. What is this reaction? Addition reaction. Directly you can add both of the bromine into each carbon atom on double bond. So CH3, CHBr, single bond, CH2Br. It will form a vicinal dihalide. This is your compound B. What we are treating next one? NaNH2. This is a reaction you studied in 11th grade. Maybe they can ask, okay. NaNH2 in presence of ammonia. Dear student, what is NaNH2 called? Sodium amide. Sodium amide. Sodium amide. It is a very important. It is a very strong base. Okay, it is a very strong base. Sodium amide is a very strong base. So what will happen? You know, alcoholic KOH is a very strong base. In presence of a strong base, what will happen? Beta elimination can happen. NaNH2 is a very stronger base, but there are, you can see there are 2 halogen, so 2 times beta elimination can happen. Okay, so let me do the first beta elimination. Let me eliminate this bromine. This eliminates. So bromine I am taking from alpha carbon. One hydrogen let me take from beta carbon. So I will get the compound CH3, CH double bond, CH single bond, Br. Once again beta elimination will happen because NaNH2 is a strong base. So bromine you take from alpha carbon, take hydrogen from beta carbon, make one more bond in between those alpha and beta. So final product will be CH3, C triple bond CH. What is this compound? That is what? Propyne. Propyne is the compound. Is it given? Yeah, they just mentioned alkyne. So very careful dear all. When you normally treat with the alcoholic KOH, you will get alkene. You will get alkene. When you treated with the sodium amide, it is a strong base. If you have a vicinal dihalide, then the product you can confirm it will be an alkyne. 2 times beta elimination will happen. Okay, next one. Which of the following is a geminal dihalide? What is mean by geminal? Both of the halogens are on the same carbon. Option A, right? What is option A given? Ethylidene chloride or bromide. Here both of the bromine are present on same carbon atom. Therefore, it is what? Geminal dihalide. Next. Friedel-Crafts reaction of bromobenzene. What is bromobenzene? Benzene with the bromine. Bromobenzene with the methyl iodide. What is methyl iodide? CH3I. You know, Friedel-Crafts reaction, the catalyst is which one? Anhydrous AlCl3. What is the upcoming electrophile? You know, Friedel-Crafts reaction, nitration, sulfonation, Friedel-Crafts acylation, all are belongs to electrophilic substitution reaction. You know, which is the electrophile here? I minus CH3 plus. This is the electrophile, electron deficient compound. Where this electrophile can attack, on which position in benzene? That depends on the existing group on benzene. What is the existing group on benzene? Bromine. Halogen directly connected on benzene ring act as a ortho-para directing group. Correct. So CH3 can goes to either ortho position. Br is there. One is This one is on the para position. One is on the para position. Ortho-bromotoluene, para-bromotoluene will be the product. So what is that? Option C. You will get both. Okay, you know, you studied that ortho-para directing group mean not one. They will give you both product. Among that, you know, para will be the major and ortho will be the minor. Correct. So ortho and para-bromotoluene, both of them can be formed. Next. When vinyl chloride is passed through alcoholic KOH, what will happen? What is vinyl group? CH2 double bond, CH single bond, chlorine. Vinyl chloride, when you pass through alcoholic KOH, what is alcoholic KOH? Beta elimination. What is beta elimination, dear all? Take your halogen from alpha carbon, take a hydrogen from beta carbon, make one more bond in between alpha beta. What is the product, dear all? Alkyne. What is this alkyne? Ethyne. Ethyne is also known as what? Acetylene. Ethyne is also known as what? Acetylene. Okay. So your product is which one? Option third one. Very careful. See, if still it is an alkene, again if it undergo beta elimination, it become alkyne. Okay. Ethyne is also known as acetylene. Next one. Name the reaction. I won't explain this one. You have to say the answer. What's that? This is a R plus and Cl minus. This is NaI. Sodium iodide in dry acetone mean only one reaction, which is the Finkelstein reaction. Correct here? Iodine is exchanging the chlorine. You will get Ri. This is called what? Finkelstein. Not Finland, Fragland. That is Finkelstein's reaction. Option B. Which of the following sequence of the reaction? They want to know the final product. Okay. What is the starting material? 1 bromopropane. Okay. This is the starting material, 1 bromopropane. They are treating with the alcoholic KOH. Again, beta elimination is coming. Let's do. Take halogen from alpha. Take one hydrogen from beta. Make a double bond between alpha beta. Okay. Product is ready. This is your compound A. Now let me treat with which one? HBr. Peroxide is there? No. Peroxide is not there mean Markovnikov rule. So H plus Br minus is there. Br minus you can add into carbon containing less number. H plus into more number. So product will be CH3 CHBr CH3. 2 bromopropane is the B product. What is the last one? Last is aqueous KOH, not alcoholic. Okay, aqueous. Aqueous KOH means what? Nucleophilic substitution. Remove bromine and OH group. So your product will be H1. CH3CHOH CH3. What is the product? Propan-2-ol. Correct. Propan-2-ol. Answer is option B. Simple reactions. Now, the reaction of toluene with the, okay, this already we discussed before. Toluene. Reacting with which one? Chlorine in FeCl3. Reaction, chlorine in presence of FeCl3. Electrophilic substitution. Methyl group is a ortho-para directing group. So chlorine can goes to ortho position and chlorine can goes to para position. Correct. Ortho-chlorotoluene, para-chlorotoluene. Ortho and the para-chlorotoluene. I think we discussed the same question before. Yeah. Next. Arrange the following alkyl halide in the decreasing order of SN1 reactivity. What is the order of SN1 reactivity? Tertiary greater than, secondary greater than, primary. Okay, let me just write it faster. What is the first compound? CCCCl. What is the second compound? C double bond, C and Cl, CH3. And third compound, CCC, which contains Cl and another carbon. Here all, here chlorine connected carbon directly connected to only one carbon. It is a primary haloalkane. Here chlorine connected carbon directly connected to 2 carbon, secondary haloalkane. Here chlorine connected carbon directly connected to 2 carbon, secondary haloalkane. So we can confirm first one is the least reactive. Yes or no? Primary is the least one. Among, question is SN1. Okay, among the first one, sorry, the second one and third one, which one can undergo reaction faster? You know, SN1 reaction mainly depends on the stability of carbocation. Yes or no? Stability of carbocation. So let me remove the carbon, sorry, the chlorine. Okay. The first case, I am removing this chlorine, I will get this carbocation. I am removing this chlorine, I will get this carbocation. And I am removing this chlorine, I will get this carbocation. Can you please name the carbocation like a primary, allyl, benzyl, phenyl, like that? The first one, I think it is a primary carbocation. Why? Because that carbocation directly connected to only one carbon. What about secondary? Secondary, that carbocation directly connected to two carbons. So it is a secondary one. Beyond secondary, it is allyl. It is allyl. Can you see? Carbon, carbon, double bond carbon. It is allyl group. So what is this? Allyl group. And what about this? This is purely secondary. In part 1 video, I already given what is the stability order of carbocation. As per this, let me tell you, allyl carbocation is more stable than secondary greater than primary. Hope you studied from the first video. Allyl carbocation is more stable. So the second compound is ready to undergo reaction faster. So second one, third one, first one. Second one, third one, first one. That is option third. Okay, 2, 3, 1. Okay. Now you can see there is a reaction. Don't worry by looking the reaction. Oh my God, what a bigger compound. Not like that. Try to understand what's the reaction. You can see here chlorine is there. So it is a haloalkane because it is connected to CH2 carbon, sp3 carbon. It is treating with the sodium in dry ether. What is the reaction? Woods reaction. Correct. What is that? Woods reaction. Okay. Both of the halogens are present on the same compound. Correct. So those carbon will join together. But they given by looking the option, you can see they are considering two same compound like this. Let me draw the possibilities. Okay. This is one of the possibility, benzene ring. Here you have CH2 with the chlorine, and here you have CH2 with another chlorine, and here you have CH3. Okay, let me just draw the shape once again. Okay, once again let me draw. This is, we have CH2Cl. This is the one CH2Cl, and here we have CH3. Okay, dear all, let's go. In the first compound, let me take the same one more compound and I am writing as it is in the opposite direction. Okay, just I am writing the same way. I am writing the compound. So this is benzene ring. This side we have a CH2Cl group. This side not this side, right? Down. The down part which contain a CH2Cl group, and this one contains CH3. Okay. So what is the reaction? Woods reaction mean you have to remove the chlorine. So you have to combine the remaining product, right? So what we have to do? Remove this chlorine, this chlorine, and this carbon you make a connection with this carbon. This carbon you make a connection with this carbon. So let me just remove the deleted or eliminated part. Okay, this is the product you are getting. Can you identify this product in any option? Option A is correct, right? Option A, you can see this CH3, this CH3 and this CH3 here. You can see, no, CH3. In between there is a CH2. Yeah, CH2. Here also CH2. Yeah, CH2. But careful. There is an option 4 given both 1 and 2. Possible or not? That's also possible, right? It is not compulsory this compound should be aligned in the proper way or in this way. It can be just opposite. So first compound I am writing as it is. Second compound I am writing just ulta. So let me write the second compound, same compound in another way. How we can write? CH3 I am writing here. Okay. CH3 I am writing here, and the CH2Cl. And the remaining CH2Cl, I can make it here. There is one CH2Cl here. There is one CH2Cl here. So what will happen? All the chlorine we can eliminate. Chlorine, 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 try to eliminate. So they will make a bond. Let me write. This chlorine, chlorine eliminated. Chlorine, chlorine eliminated. Let's make the bond here. This and this. See, this is also possible, right? The methyl group can be opposite. That's also possible. So here answer is which one? Both 1 and 2. Both 1 and 2 are possible. This is Wood's reaction. Okay, next. What is the correct order of reactivity for halides is? Correct order of haloalkane. They didn't specify which reaction. Allyl, vinyl, propyl. We discussed no. Stability of carbocation of this kind of chloride. What is the stability order I given for the entire thing? Once again I am repeating. Most stable carbocation is tertiary. Then we have benzyl carbocation. Then we have allyl carbocation. Then secondary. Then primary. Then methyl carbocation. And the least one is vinyl carbocation. Here all. So vinyl is given. Okay, vinyl is there. Allyl is given. Okay. Propyl. What is propyl group? CH3, CH2, CH2. Propyl chloride. If it chlorine eliminated, this is the carbocation. Here the carbocation directly connected to only one carbon atom. It is a primary. It is a primary. So what is the order dear all? Allyl greater than, primary greater than vinyl. So our allyl greater than, propyl greater than vinyl. Allyl, propyl, vinyl. Where is that? Allyl, propyl, vinyl. Option C is the correct answer. Related to SN1 mechanism, stability of carbocation. Now, one of the following that cannot undergo dehydrohalogenation is. Simple question. You just look into the question once again. Which of the following compound cannot undergo dehydrohalogenation? What is mean by dehydrohalogenation? Beta elimination. Correct. Means one hydrogen and one halogen we want to eliminate. What is that? Option A given isopropyl bromide. It is a haloalkane. Ethanol. It is an alcohol, right? Alcohol contain halogen. Alcohol contain halogen? No. So how we can perform dehydrohalogenation? Then the ethanol compound doesn't contain halogen. Then how you can eliminate halogen? Right. Option B is the one. Option A and C contain halogen. So they can undergo beta elimination. X compound react with the sodium to give CH3, CH2, CH2, CH3. What is the compound X? What is the product? Butane. Your product is CH3, CH2, CH2, CH. This is your product. X compound react with the sodium. So sodium means which one? It will be Wood's reaction, right? Okay. So what compound you want to take? CH3, CH2, Cl, ethyl chloride. Take one more ethyl chloride, CH3, CH2, Cl. Mix with the 2 sodium metal. What will happen? 2 sodium chloride eliminated. Ethyl will combine together. We will get butane. So in order to get butane, we have to check it ethyl chloride as per Wood's reaction. Okay. Now complete the reaction. Starting material is given CH3, CH2, Cl. Treating with which one? KCN. When a haloalkane treated with a KCN, what you will get? Cyanide. KCN eliminate, you will get CH3, CH2, Cn. Propan cyanide or propan nitrile. This is your compound X. When it is treated with the H3O plus on heating, what will happen? Dear student, this reaction actually we are discussing in one of the chapter aldehyde, but still all of you listen carefully. First reaction is clear, right? Halogen is removing, cyanide is substituting. You are getting this compound X. This compound X, when you treated with the H3O plus, what is mean by H3O plus? You know, hydronium ion, or it is called acid hydrolysis. You keep in mind, cyanide when undergo acid hydrolysis. Why it is called acid hydrolysis? H3O plus ion, how you are getting here? H2O plus H plus. Correct. Acid hydrolysis. Cyanide on acid hydrolysis is converted to carboxylic acid. Okay. CH3, CH2, COOH. Keep in mind, cyanide on acid hydrolysis converted to CH3 acid, CH3, CH2, COOH. What is the formula of this compound? There are total 3 carbon, C3. How many hydrogen? 3 plus 2, 5, 5 plus 1, 6, and 6 are O2. C3 and 6 O2. C3 and 6 O2. Option A is the correct one. Okay? Now, the compound A, it's a very important question. Compound A form B. Okay. Compound, okay, let me write the data here. Compound A forming B. Huh? With the sodium metal. Okay, with the sodium metal. And again A form C with the what? PCl5. Okay. But B and C form, but B and C combine together and forming diethyl ether. What is diethyl ether? This is ethyl group. This is what? Another ethyl group. In which ether? Right? Diethyl ether. Okay, fine. What is the compound A, B, C? Very simple and very tricky question. Okay. This is ether, right? This is ether. Let me make a back calculation. How you prepare ether? By Williamson synthesis through the reaction of one haloalkane with a sodium alkoxide. Why I selected Williamson synthesis here? Because sodium is there, halogen is there. Okay. If I want to get this ether, what haloalkane and what sodium alkoxide I want to choose? I can write CH3, CH2, Cl. Chloroethane, I can react with the CH3, CH2, ONA. What? I can take chloroethane, I can react with the sodium ethoxide. So sodium and chlorine eliminated, I will get this ether. Now you come back to, but I don't know which is B, which is C. A is treating with the sodium, you are getting B. So A, what it can be? What can be? Option A. You see your option, given option, all are ethanol. So let me start with A. A can be ethanol. CH3, CH2, OH. Okay. Ethanol, when you treat it with the sodium, what happened? This hydrogen eliminated by sodium or replaced by sodium, you will get CH3, CH2, ONA. Yeah. This is your compound B. When A, what is A? Ethanol treated with the PCl5. You know, PCl5 is a chlorinating agent. It will eliminate the chlorine by Cl group, CH3, CH2, Cl. So this is your compound C. Correct? So identify A, B, C. A is ethanol, B is sodium ethoxide, C is ethyl chloride or chloroethane, right? Option A is the correct answer. Okay, practice it again. Now, the conversion of ethyl chloride into diethyl ether takes place by, that I think already we discussed. What is that? Preparation of ether is called Williamson synthesis. Fluorobenzene can be synthesized in the laboratory by, we studied from aniline. We know aniline, NH2. Aniline, first we do that diazotization, NaNO2 with HCl, 0 to 5 degrees Celsius. What we are getting? Benzene with N2 plus Cl minus. You know, benzene diazonium chloride is a very important compound. You can prepare so many important compounds from this one. We prepared chlorobenzene, we prepared bromobenzene through Sandmeyer and Getterman reaction. When you treat it with a warm potassium iodide, we will get iodobenzene. How you are getting fluorine? Fluorine we are treating by HbF4. What is HbF4 is called? Fluoroboric acid. Correct. What is happening here? Very simple. HbF4 contain H plus and BF4 minus. So this H plus and Cl minus eliminated as HCl. So what we will get? Benzene with the N2 plus and this BF4 minus connected to the cation. Which on heating? When you simply heated, this nitrogen gas is evolved From BF4, one of the fluorine attack on benzene ring, we will get fluorobenzene. And what is the remaining one? BF3. This is the product. So fluorobenzene you can prepare from benzene diazonium chloride by treating with which one? Fluoroboric acid. This reaction you may study the name. This is known as Ball-Schiemann reaction. Ball-Schiemann reaction. Okay, Ball-Schiemann reaction. So what is the answer, student? Fluorobenzene can be synthesized in the laboratory. Yeah, from aniline by diazotization followed by heating with the diazonium HBF4. Yeah, option B is the correct. Now, 1-chlorobutane on reaction with 1-chlorobutane. What we have? 1-chlorobutane. Okay, that means CH3. CH2, 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 CH. 1-chlorobutane when we treated with the alcoholic potassium hydroxide. Beta elimination, right? Take chlorine from alpha, hydrogen from beta, make a double bond between alpha beta. So you will get but1ene, 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 but1ene. Right? Option A can be the answer. PVC, you know PVC, polyvinyl chloride. It is produced by the polymerization of which one? Dear student, the polymer name is PVC, polyvinyl chloride. So what is the symbol unit? Vinyl chloride. Many vinyl chlorides are combining together. We are getting PVC. So what is that? Vinyl chloride. What is vinyl group? CH2 double bond CH with chloride. Vinyl chloride. Now, most readily hydrolyzed halide is. Which halide can undergo easily hydrolysis? Hydrolysis means what? Reaction with the water, dissolving in water. Aqueous is the medium, correct? In aqueous medium, it is a polar protic solvent. Which substitution we will consider? SN1 mechanism. In a polar protic solvent, we will prefer SN1 mechanism. Question is indirect, which will undergo SN1 reaction faster. Okay, option A. Option A given chlorobenzene. Option B given there is a diphenyl group on CH, correct? One phenyl here, one phenyl here. Alright. What is option C? C6H5CH2. Benzyl chloride. Okay, benzyl chloride. Alright, benzyl chloride. Option D. What is option D? C6H5 thrice. C6H5 thrice, which means there are 3 phenyl group on one chlorine. Okay. Sorry. So dear all, which compound can undergo SN1 reaction faster? You have to remove the halogen, right? Chlorine you have to eliminate. This is the carbocation. What carbocation is this? This is phenyl. Phenyl carbocation, right? Phenyl carbocation. Benzene with the A positive, phenyl carbocation. It's very least stable, okay? So it won't undergo reaction. Option B, if you remove this chlorine, you will get this carbocation. You know, it is a secondary carbocation. Why? Because this carbon connected to 2 carbon atom. But it is highly stable, no? Because resonance is possible. To the both benzene ring, resonance is possible. What is option C? If you remove this chlorine, you will get, what is this called? Benzyl carbocation, right? Benzyl carbocation. What about option D, dear all? This is the one. It is a tertiary. But you see, as per the order we studied, benzyl is more. Benzyl, what is the stability of carbocation I given? Tertiary greater than, benzyl greater than, allyl greater than, secondary primary, right? So first one is phenyl. Phenyl is least one, don't worry. B compound is secondary. This is benzyl. This is tertiary. Which is highly stable? Tertiary is highly stable. Because you see, on the carbocation, 3 phenyl groups are waiting to make resonance. Highly stable. So compound number D is ready to undergo reaction fast. Next, in the following compound, which will give least number of monochlorinated product. Already we discussed in one of the questions before in part 1, option D, neopentane. Correct? What is neopentyl group? one carbon connected to 3 carbon is called tetrabutyl. If it contains one more carbon is called neopentyl. If the valency all are completed, it's called neopentane. Correct? Neopentane. Neopentane, when you do chlorination in presence of light, what you will do here? You will remove one of the hydrogen from any of the CH3 and you will add chlorine. If you remove hydrogen from any of the CH3 group, you will get the product only one. So one chlorine containing only one product you will get it in neopentane or 2,2-dimethyl propane. So your answer is option D. Part 1, I think we discussed this question. Okay. Now, among the following, which one has weakest carbon halogen bond? Weakest carbon halogen bond. All of you, let me write the structure of each compound. Option A, benzyl bromide. What is benzyl group? Benzene with the CH2Cl. What is option B? Bromobenzene. Okay, bromine on, there is a benzene ring. Okay. What is option C? Vinyl bromide. Vinyl bromide. Okay, what is option D? Benzyl chloride. Okay, benzyl chloride. Okay. Which among the following having weakest carbon halogen bond? This is the carbon halogen bond here. 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 Where you can find out weakest. Weakest. How to identify? No doubt this is strongest, right? In haloarene, it will undergo resonance. So there will become a double bond. Double bond is stronger. So not option B. And benzyl bromide, benzyl chloride. Okay, first option bromide, right? Sorry for that. Not chlorine, bromide, right? Yeah, bromide. Okay, benzyl bromide and D is benzyl chloride. And what about this is vinyl? Vinyl chloride means this is a double bonded carbon, sp2 carbon. In sp2 carbon, what is the which one? S character, 33.3%. Correct. What about here? Here chlorine connected carbon is a single bonded carbon, sp3. Therefore, 25%. So here also this is 25%. S character increases mean, I told you the electronegativity of that element increases. Means that will hold that element very tightly with electrons. So option C having greatest means vinyl chloride contain greater S character. So this carbon having high electronegativity, it will hold that chlorine little bit tightly. So you cannot leave the chlorine immediately. So it is little bit stronger. Not stronger than haloarene. Okay, it's little stronger. So your option is either A or D. Which one? Only the difference is halogen. Chlorine and bromine. Chlorine and bromine. Which is the best leaving group? Top to bottom, in case of fluorine, chlorine, bromine, iodine, their reactivity increases. Correct or not? Their reactivity increases. Down the group, it is easy to remove the group. So, which is better to leave? Bromine is ready to leave because of the bigger size, the bond is weaker. Right? Bond will be weaker. Answer is which one? Option A. Next one, tetrabutyl chloride preferably undergo hydrolysis by tetrabutyl. What is tetrabutyl? One carbon connected to 3-methyl group. Tetrabutyl chloride. Tertiary. It is a tertiary haloalkane. Tertiary haloalkane prefer to undergo SN1 mechanism. Not both A and B or any of them. SN1 mechanism clearly mentioned. Next one. CH3 tri-CMgCl. So one carbon connected to 3CH3 group with the magnesium with the chlorine. What is this? A Grignard reagent, correct? This is a Grignard reagent because it contains a alkyl group, magnesium and halogen. What is the charge? Magnesium positive, carbon negative. Okay. It is treating with which one? D2O. Same question we discussed, but pattern is different. Okay. We are treating with which one? D2O. D2O contain which ion? D plus and OD minus. If it is H2O, H plus and OH minus. Similarly, AB water. What you have to do? Just to interchange the cation and anion to the negative position. You add D plus. So you will your compound will be CH3 thrice D plus. What is the byproduct? MgCl already there. To the Mg plus OD minus will attack OD. So I think this is the product given, not directly like this. What is this? One carbon is there and 3 CH3 is there. One deuterium. CH3 thrice CD. CH3 thrice CD. What is that? Option A. Correct. Next. What is this reaction? What is this reaction is called? Many time we discussed. Breathing with which one? Aqueous KOH. Aqueous KOH which one? Nucleophilic substitution. Here this halogen is going and OH nucleophile is substituting. What it is? Nucleophilic substitution reaction. Which is the most reactive for SN2 reaction? SN2 reactivity order, you know, primary greater than, secondary greater than, tertiary. Unfortunately, all the options are given like primary. At the same time, on primary we can judge it. You know, SN2 mechanism always try to prefer takes place in lower haloalkane. Simple thing, because of steric hindrance, right? Bulky group means steric hindrance come. As molecular mass increases, steric hindrance come, which is the least compound CH3I. All leaving groups are iodine only, correct? All the compound contain iodine. So which is better to leave. If the alkyl group is smaller, it can easily attack. Steric hindrance is minimum, easy to attack. Next one. Which statement is correct? Option A. Ethyl bromide reacting with the alcoholic KOH it form ethanol. Is it? No. If you treat it with the alcoholic KOH, it will undergo beta elimination and it will give you alkene, right? Not alcohol. What about option B? Ethyl bromide when treated with the metallic sodium, it will give ethane. No. When you treated ethyl bromide with the sodium, double Woods reaction, you will get butane, right? You will get butane. C. Ethyl bromide when treated with the sodium ethoxide, it will form diethyl ether. Yes, that's correct. You will get which one? You will get a Williamson synthesis. Let me check you. C2H5Br, CH3CH2Br, treating with the sodium ethoxide. Sodium ethoxide. What is happening here? Sodium and bromine eliminated, we will get ethoxyethane, right? Ethoxyethane. So what is the product or what is the correct statement? Option C is the one. And what is the last one? C2H5Br treated with AgCl, you are getting cyanide. No. When you treated a haloalkane with AgCl, what you are getting? Isocyanide. Careful. Next one. SN1 reaction is favored by, you know, SN1 reaction favor in non-polar solvent. No, SN1 reaction favor in polar protic solvent. So not that. Option B, more the number of alkyl group on the carbon atom attached to the halogen atom. Yeah, right. SN1 reaction favor in tertiary group. If the halogen connected carbon directly connected to 3 carbon atom, yeah, by the removal of this halogen, you will get a more stable carbocation, correct? If more number of alkyl group, how many alkyl groups are here? 3. More the number of alkyl group on the carbon atom attached to the halogen, it will favor SN1 mechanism. Yes, tertiary will prefer to undergo. Option C what? Small group on the carbon. No, none of this. Okay, option B. In a group of isomeric alkyl halide, what is the order of boiling point? Very careful, very careful. They given isomeric alkyl halide. For example, let me take the compound CH3, CH2, Cl. It's a primary, right? It's a primary haloalkane. Let me take CH3, CH3, and so here we can take one another case. Let me just rewrite one another structure. CH3, CHCl, CH2, CH3. It is secondary, right? Okay. Let me take a tertiary, all of you. Tertiary butyl chloride. This is what? Tertiary butyl chloride. See their isomer, right? They are isomer haloalkane, primary, secondary, tertiary. Which one having boiling point greater? You know what isomer mean? No need to worry about the mass. Mass is similar, no? Okay. Then second one you have to check it branching. You know, branching increases, boiling point decreases. The first compound contain no branches, all surface area very greater. So first compound having greater boiling point. So boiling point is primary. Secondary contain branches, but the tertiary contains so many branches. So secondary, tertiary. What is the correct order of the boiling point? Tertiary greater than, secondary greater than, sorry, primary greater than, secondary greater than, tertiary. Primary greater than, secondary greater than, tertiary. Option D. Option D. Correct. Okay, dear all. Very simple question we already discussed in part 1. Which is the best method of preparing alkyl halide? Which is the best method? All of them can be used, right? PCl3 fine, PCl5 fine, but which is the best method? SOCl2, thionyl chloride, because the product is RCl along with HCl and sulfur dioxide. You know, both the byproducts are gases. Byproducts are gases mean easily escape from the system. You will get pure haloalkane. This is the best method. Correct. The next one, the organic compound which shows complete stereochemical inversion. Inversion is happen in, you know, SN2 mechanism. Retention is happen in SN1 mechanism. We discussed in part 1. Okay, the question is simple. Which will undergo SN2 reaction faster? What is the reactivity order of SN2? Primary greater than, secondary greater than, tertiary. Let me just elaborate the compound A. What is A? C2H5. Okay, CH in which 2 ethyl group, CH2CH, CH2CH3, CH2CH3. Okay, then 1 chlorine. What is option B? Tertbutyl chloride. Option B is tertbutyl chloride. What is option C? CH compound connected to CH3, CH3 and 1 chlorine. And what is option D? CH3Cl. Okay, fine. Let's go. Dear all, here chlorine connected carbon directly connected to 2 carbon, secondary. Here chlorine connected carbon directly connected to 3 carbon, tertiary. Here chlorine connected carbon directly connected to 2 carbon, secondary. Here chlorine connected carbon is just one a primary. SN2 reaction favor less steric crowded haloalkane. What is the option? D. Correct? D. Smallest one. D. Then, which of the following reaction will yield the 2,2-dibromopropane? What we need? 2,2-dibromopropane. This compound we need. Okay, let us check it with the option A. What is option A? CH3C triple bond CH. What is this? Propyne. They are treating with what? 2 HBr molecule. Let me treat with the 1 HBr first. When you add HBr, peroxide is there? No. So, Markovnikov's rule. Br minus added to carbon with a less number hydrogen with a more number. You will get the compound CH3CBr double bond CH2. 1 more HBr is there? No. Okay, let me add the HBr once again. What you will get? H plus M, Br minus is there. Br minus added to carbon with a less number. This is with more number. So what you are getting? Yes. This is our product. So first compound itself, we are getting the compound 2,2-dibromopropane. You can check with the others also. Okay, you won't get it. The answer option B is. What is the IUPAC name of the given compound here all? Very simple question. Halogen is there, bromine and chlorine. But the major functional group here it is double bond. Double bond should get least number. And the other chlorine and bromine should get least number. So I think this is number better, right? 1, 2, 3. Bromine is there, chlorine is there. Alphabetical order, B is first. So what we can say? 3 bromo, 1 chloro, cyclohexene. 3 bromo, 1 chloro, cyclohexene. Right? 3 bromo, 1 chloro, cyclohexene. Option C is the answer. Okay. 2-methyl butane. What is the compound? 2-methyl butane. 2-methyl butane on reaction with the bromine in presence of sunlight, in presence of light. Here all, when a hydrocarbon treated with, especially alkene, when you treated with a halogen in presence of sunlight, what will happen? It will undergo free radical mechanism, free radical substitution reaction. How free radical is forming? By the homolytic cleavage of bond. You know that. Let me add bromine. The question, where I can add bromine? You can add to any of the carbon, but the question is, which is the major product? Okay. What is the stability order of carbocation? Tertiary greater than, secondary greater than primary. This is the same order of stability of free radicals also. Okay, so free radical stability is in the same order, tertiary greater than, secondary greater than primary. Alright, so how you can make it tertiary? From this compound, how you can make it tertiary? That is the question. Here all, let me do one thing. I am taking this hydrogen. I am just drawing the hydrogen like this. Okay. One electron goes to the hydrogen. One electron goes to this carbon. What you will get? You will get the compound CH3, CCH3, CH2, CH3. Dot. You know, odd electron species are called which one? Free radical. It's a tertiary free radical, right? Because that free radical connected to 3 carbon atom. Yeah. H is leaving as H dot. So Br2. What is Br2? Br with the Br. One electron here, one electron here. So one of the Br dot come here, and these two electron will join together. We will get the final product, which one? CH3, CCH3, Br, CH2, CH3. What is this compound, dear student? What is the name of this compound? This is 1, 2, 3, 4. Second position bromine, second position methyl. 2 bromo, 2 methyl. 2 bromo, 2 methyl butane. Correct? 2 bromo, 2 methyl butane. Same like carbocation, what we are doing. Here itself, within the compound, there is a chance to make it tertiary. Already there is a tertiary, then no doubt. Next. Which of the following is the most reactive towards SN1 reaction? Which is most reactive towards SN1 reaction? Okay, I am just rewriting the structure once again. C6H5C. What is C6H5? Phenyl ring with one carbon. That carbon connected to CH3, and it is also connected to one benzene ring with there is a bromine. What is option B? C8H5CH2Br. I think there is no need to discuss about C8H5, not like a benzene ring. It won't give you any stabilization, right? C8. Okay. So C8H5CH2Br. If you eliminate bromine also, you are not going to get a stable carbocation. It's not benzene ring. Option C. C6H5. Okay. C6H5 means phenyl ring with one CH carbon. On the CH carbon, again one phenyl ring with one bromine. Okay. What is option B? C6H5 phenyl ring with one CH carbon, and there is a CH3 carbon with one bromine. Question, dear student, SN1 mechanism. SN1 mechanism, right? SN1 mechanism is followed by the stability of carbocation. Okay, let me delete the carbocation here. So what you will get carbocation? This is tertiary, right? Because that carbocation directly connected to 3 carbon. One here, one here, one here. Tertiary. Okay. What about option B? Okay, I told you this is not a benzene ring. It won't give you stabilization. Option C. Take this bromine. So this is the carbocation. What carbocation is this? This carbocation directly connected to 2 carbon. Secondary. What about here? This carbocation, it is also connected to 2 carbon, secondary. So secondary, no problem. You know the stability of carbocation. Tertiary is most greatest one. Option A is the answer. Okay, dear all. So we completed nearby 150 MCQs for the chapter Haloalkanes and Haloarenes, the most important organic chapter. So part 1, around 90 questions are there. Remaining questions we are discussing in part 2. This questions is more than enough to practice at least 1 or twice. You see this video and try to understand the concept. Still, if you have any confusion, you can contact the faculties in Brilliant Center. We will be here to help you to get a maximum marks in term 1 examination. So dear all, we will meet again with some other chapter. Totally you have 6 chapters for your term 1 examination from chemistry. We will meet again with the other chapter with so much important MCQs. Okay? Thank you all. Bye all of you. Wish you all the best. Try hard and get best.